Hey guys, this is Carl with Mesos Analytics. In this course, we'll review the overall scheme for an automated machine learning pipeline with Mesos. We will present you with your run-of-the-mill job scheduler or dispatcher, and we make reference to our flux propagator, which broadcasts tokenized strings acting as replicated state machines. The Lightbent fast data platform is an example of this. And notice how Flink and Spark are actually embedded adjacently, since you're running a MapReduce across the cluster spectrum, if you will. So we know that we need a prop type checking mechanism for a contextual switch, and in this case we're going to partition this set and consider the process of insertion and deletion in linear time. And we can do this by adhering to that mutex-friendly structure of transpiling JavaScript on the browser. And don't forget, we want to mimic or simply abstract the configuration for a zookeeper mask. And the zookeeper mask is derived from this bundle of Webpack dispatchers that you can statically predetermine, and adhering to that DOM-friendly, React DOM-friendly, we're talking about the DOM tree of the browser, and heapifying. So in this case, you're heapifying a class inside the collection of dependencies. With Webpack, you have this abstraction. And so what's exciting about this part of the course is that we're going to explore the new React VR, or React 360 as it's now called, this library from the React team that allows you to play with WebGL using a Euler 4-parameter coordinate mapping. This should remind you that the functionality of the app extends is most likely linear, but you could have a worst case of log n. And because of this, it's just best to stick with the stack approach. But bear in mind that with Zookeeper, processes of distributed applications are provided a per client guarantee of a queue of requests, of linear associative arrays, so it would give you that hash table efficiency that you can find attractive in this case. So focusing on the code that we're actually writing, we're finishing off the mechanism to actually display a pie chart or a dynamic sunburst D3 vectorized circular or spherical tree, you can learn more about Sunburst and D3JS with Material UI. And in this case, we're going to pass a transformation to become a 2π object, and the total resources in every single parameter will be an object in and out of itself, an object with attributes. And we use Lodash to do the heapifying that I described earlier. And everything is just passing this broadcast onto the right porting. Zookeeper was built with the mentality of blocking primitives, such as locks, blocking primitives for a coordination service. And so the implementation of the service itself actually becomes more complicated if, for example, processing requests depends on responses, which can become more complicated if the processing requests depend on a latency of sorts. And so we question, is this the right way to do distributed computing? The navigation class is essential in this case to abstract the UI objectification and component Latin programming style, which we've depended on throughout the course. That is the essence of React. We're initializing or instantiating, if you will, the model aspect of the MVC, but in a flux directed acyclic graph, one loop mentality of dealing with data as if it were a forward iterator. A forward iterator making an interaction with the input and output. In this case, we're scraping a stream of metrics which has been set up with Prometheus, the node exporter, and having this CSV friendly information can give you the ability to maybe take a snap of the current state of the clusters in terms of CPU bandwidth. There are a few articles out there making reference to the 4 golden signals of DevOps or sysadmin. But I think it's essential to present this information in a dynamic, mobile-first, browser-friendly, reliability engineering of an application, of a distributed application, using the Zookeeper priority queue structure.